Okay, we want to look at measures of central tendency in this video, but I just want to give you a tip. You may get data which is already grouped in a table and whatever, and you may need to find the class width. So you must know that the class width, because you're going to need it when you want to put all these other things like the upper class boundaries, whatever. For you to find class width, the formula is just, for you to find class width, you'd say it is the upper class limit of one class minus the upper class limit of the class before that. Okay, so you can say the upper class limit of the class behind minus the class ahead minus the upper class limit of the class behind, or the upper class boundary of the class ahead minus the upper class boundary of the class behind, or the lower class limit of the class ahead minus the lower class limit of the class behind. So it is, if you're dealing with, to get class width, you either say lower class limit minus lower class limit, or lower class boundary minus lower class boundary. You'll be saying the one ahead minus the one behind. You never say lower class or upper class boundary minus lower class boundary and grade. No. Of course, for class boundaries, yes, it can work, but always, just to be safe, just know that it'll be the upper class boundary of the class ahead minus the upper class boundary of the class behind. Okay, right. For class boundaries, we know it's a bit different, but we still just use that. Know that as your principle. Now here we are dealing with measures of central tendency, and we want to see for ungrouped data, okay, and then for grouped data. So we're going to put it together. We want to see the summary. We want to see the 6, because there are 6 measures of central tendency. Measures of central tendency are also called measures of location. Remember what we'll be just looking for here when we deal with measures of central tendency. We're looking for a key value that can describe our data, okay? A value which says something, which helps us to know about, to understand the data. It's one value which is going to represent the data in some way. Measures of dispersion just give you an idea of how the data is spread out and whatever. So here we are going to be dealing with the measures of central tendency, or measures of location. First, I'm going to push this thing here, and group data and ungroup. Then here I'm going to put a column which is going to be for each of the measures of central tendency. Okay, we start with the first one, and we can do the 3 M's, which is mean, median, and mode. So let's deal with mean for ungrouped and for grouped. You see, the measures of central tendency, these measures where we have one value telling us about the info we want. Okay, we can't look at the whole thing. We want one value which kind of tells us how the people are performing or what is going on, and that is a measure of central tendency. It is a value which describes data. So we'll be saying we want that single value, and either it could be the mean. The mean describes your data. It tells you the average. There's something that it tells you. The median also tells you the once it's a value which lies in between your data. It tells you something. The mode also tells you something about it, because it is the data which is appearing the most. Then we have quartiles, we have deciles, we have whatever, which tell us something about the first quarter of the work, or the second, or the first 3 quarters, the 75% of the thing, whatever it is. So now when we deal with mean, we start with mean. Mean is going to be, you see, for mean and for variance, which you're going to do in measure of dispersion, you must separate the population and the sample. Okay, these are the only 2 things that do that. Okay, so for mean, we need to know sample mean, and we need to also need to know population mean. Okay, population mean, right? Sample mean and population mean. Now what you must know is that sample mean is going to be x bar, and population mean is going to be mu. Now populations, the things to do with populations, we represent them using the things to do with population, we represent them using Greek letters. That's why you're seeing this mu. So if you see this mu, it is the mean of the population. So this is just going to be the sum from 1 to n, the sum of all x terms, and you divide by the number of terms, which, if it's the population, it's a capital N for number of terms. For sample, you're going to say this x bar is going to be the same thing, the summation of all x values from 1 to n divided by the number of terms, but for here we use a small n. Now this kind of already tells you why in tutorial 5 you have to know the summation symbol, because you're going to use it in these formulas a lot. So this is the sum when you have ungrouped data, which is data that is listed 1 like this. Now for grouped data, of course, we don't have this population and sample, but it's just one mean, which is x bar, and we call it the grouped mean. Okay, group mean, you can have the group population mean or whatever, but we just have the group mean for your work here that you are doing. It's just going to be group mean. And to get the grouped mean, now what you must know is when you go to grouped data, wherever there was an X, it will now be an FX bar, okay? Because group data number 1, you'll be having frequency, right? So frequency should now come into play. And also, you need to use the mid value, the midpoint. So you'll be saying here that it's going to be the sum from 1 up to k of midpoint, which is wi. That's the x value that we use, but you should multiply by how many they are because it's now grouped. So x, you are going to see xi as wifi. It's just xf, okay? But the x that we deal with here is the midpoint, which we call w. Midpoint is just the mid or x value. It is an x value, so don't be confused. And k here represents the number of intervals, so that is what you'll be having. It's sum from 1 all the way to k, which is the number of intervals. You divide, so this is what you're going to add to put in the denominator, the number of, so it's from 1 up to k of the frequencies. So this is what happens. You add all the frequencies and you find the total frequency. This is what you do, and this is going to be the group mean. Now let me be faster, all right? So this is the first one. We are done with mean. Now we go to the second thing. So here is our mean, and we are done with info. Now we go to number 2, which is going to be the median. So median, yes. For ungrouped data, which is things that are just listed, you should know that median is going to be, now we do it in part 1 and whatever. If you have odd number of terms, okay? If you have an odd number of terms, which is like 7 terms, 9 terms, 1, 3, 5, 7, 9, things that are not even, that you can divide by 2 and get an answer without a remainder. Odd number of terms, when you want to get the median, you can say, go to value, find value at position, find value at position n plus 1 over 2. Once you find the value at that position, the value is your median. Okay, the value, first find the value at position n plus 1 over 2. So you're going to say n plus 1 over 2. The answer you get is the position. Okay, that position, you go to that position and you find that value. That value is going to be your median. Now again, for when you have even number of terms and you want to find the median and it's ungrouped, these things are ungrouped. Now, what are you going to do? You are going to you're going to find values at the following positions. We're going to find values at positions 1, n over 2, and n over 2 plus 1. So you're going to go to these 2 positions, find the values at these 2 positions. Once you find it, median will be equal to average of those 2 values. Average of those 2 values, okay? So what should you do when you say average of those 2 values? Add them and divide by 2, okay? In other words, we're just saying add them and divide by 2. That's how you get median for even number of terms, but it's still ungrouped data. There's no frequency column here. There's no whatever. This is going to be the median. Now, the median for grouped data. So grouped data is nice because you see for measures of central tendency, we have the median, we have the mean, we have everything. But when you go to measures of dispersion, group data won't have much. Here, that is where you need to know all these things are telling you. What is the median for grouped data? Median, you just say median. There is a formula for group data. It's going to be lower class boundary of median plus then that big fraction, okay? So it's always lower class boundary plus the big fraction, then we multiply by class width outside, okay? There'll be a big fraction, then we multiply by the class width outside. And inside that big fraction, for median, it will be n over 2 minus the cumulative frequency of m minus 1. We'll explain that, divided by frequency of m. Put that. You need to be good at putting this formula. Of course, we are going to use it later. But it's the lower class boundary plus, don't forget, in your fraction, it's n over 2 minus cumulative frequency of m minus 1. O divided by frequency of m. Then you multiply by class width at n. This is going to be your final solution. this gives you your median. So when you calculate, remember to start by multiplication, then you do the addition later. This is how you get median, and you'd be done. Now we can go to the next thing, which is going to be the mode. Number 3 is now the mode, which I will do in the next video, and I'll stop here for the sake of time. In the next video, we do mode and quartiles and deciles and percentiles, and you'd be done. These will be the measures of central tendency: the mean, which you've seen, the median, which you've seen, the mode, which you see, then the quartiles, deciles, and percentiles. That is it. Goodbye for now. We'll meet in the next one.